by hand and calculate our critical numbers that way. So I know I've got to go increasing, decreasing, maxes and mins, which means I need my first derivative. So f prime of x equals, I'm going to bring the 3 in front, which means that this 3 and this 3 will cancel, so I just get x squared. Derivative of negative 2x squared would be negative 4x plus 12. Okay. And then to get our critical numbers, we set that equal to 0. It's quadratic, so you're going to all do your own magic x's. So let's see, I'm seeing 6 and 2 make that negative. So x minus 6 times x plus 2 equals 0. And we've got x minus 6 equals 0 and x plus 2 equals 0. So x equals 6 and x equals negative 2. So let's go ahead and sketch our sign chart. So my intervals would start at negative infinity. My first critical number is negative 2. My next critical number is 6, and then it goes to infinity. Then in this line chart, I actually have to pick some x values. I need to know what's going on with our derivative, and I'm going to go to my most simplified derivative, which is that there in the box. So between negative infinity and negative 2, I'm going to pick negative 10. Between negative 2 and 6, I'm going to pick 0. And between 6 and infinity, I'm going to pick 10. So I'm taking that negative 10, and I'm substituting it into here. Negative 10 in this interval, in this parentheses, would be negative. And then this one would be still negative. So a negative times a negative is going to be positive. I put a 0 in. It's negative in this first one, positive in the second one. So negative times a positive is negative. And then I put in a 10. I get a positive in the first set of parentheses and a positive in the second set. So it is positive. So what does that mean for the original function? So my derivative is positive. My original is increasing. My derivative is negative. My original is decreasing. And then, so let's do our justifications. So f is increasing on negative infinity to negative 2 and 6 to infinity because f prime is greater than 0 on these intervals. F is decreasing on negative 2 to 6 because f prime is less than 0 on these intervals, or on this interval. All right, relative maxes and mins. So I need to look at my sign chart again. I know I'm going from increasing to decreasing and decreasing to increasing. So the hill is the max, the valley is the min. So f has a relative max at x equals negative 2 because f prime changes from positive to negative at this value. F has a relative min at x equals 6 because f prime changes from negative to positive at this value. All right, so in this part, same equation, but now we've got to look at the concavity and the point of inflection. So that comes from the second derivative. So I'm going to go grab my first derivative over here. So I'm going to grab this x squared minus 4x plus 12. So f prime of x equals x squared minus 4x plus 12. I'm going to take the derivative. So derivative of x squared is 2x. Derivative of negative 4x is negative 4. Set it equal to 0. Get my critical numbers. So add 4. divide by 2, I get 2. So 2 is my critical number. I'm going to put that in my sign chart. So I am going from negative infinity to 2 and 2 to infinity. I'm going to pick some x values. I'm going to see what happens with f double prime and relate that back to the function. So between negative infinity and 2 is 0, and between 2 and infinity is 10. So I'm going to put into my most simplified derivative here. When I put a 0 in, I get a negative. When I put a 10 in, I get a positive. So when I'm negative in the second derivative, that means I'm concave down like a frown. And when I am positive in the second derivative, that means I'm concave up like a cup. All right, so let's look at that. So we're going to write our justification. Sorry. What on earth happened there? I don't know what just happened. All of the writing just went away. Oh, I must have hit erase all ink on the slide. All right, well, it was 2 to infinity, so we're going to go with that. I'm not going to try to rewrite it. So we said it was negative infinity to 2 and 2 to infinity. And I can't remember. It was 2x minus 4. So we had negative or 0, 2x, so it was negative and then positive. Okay. Okay. Hopefully I redid that right really quickly. Okay. So f is concave up on negative infinity to 2 because f double prime is less than 0 on this interval. F is concave down on 2 to infinity because f double prime is greater than 0 on this interval. And then points of inflection is just where it changes sign, so I get just that 2. So f has a point of inflection on or at x equals 2 because f double prime changes sign at this value. Okay, we got one more set of stuff to do here.